In section 9.3, we're going to be solving quadratics by graphing. In the last chapter, we were solving quadratics by factoring. Now, in this chapter, we're going to be solving those quadratic equations by looking at our graphs. So it's like combining the zero product property together with what we've learned in this chapter so far with graphing to be able to find those same answers. So just as a reminder, a quadratic equation is ax squared plus bx plus c equals 0, where a cannot equal 0, because if a equaled 0, that would make the x squared go away in our equation, which would make it not quadratic anymore, which is the standard form of the equation. So we're going to be looking at all of the equations in standard form, ax squared plus bx plus c, just like we've done so far in this chapter. But one thing to take note of is that in this section, we need to make sure our equations are set equal to 0, because we're going to be solving them by combining graphing with the zero product property. So our equations, again, have to be set equal to 0. Make sure you write that down in your notes. Let's look at our first example. It says solve x squared plus 4x equals 5 by graphing. In the last chapter, once again, we would have solved this by factoring, but now we're going to be able to graph it and solve it by looking at the graph. So again, just like I said in the last slide, always start off your problem by setting your equation equal to 0. So in this case, we would start by subtracting 5 from both sides. So we'd end up with x squared plus 4x minus 5 equals 0. So y equals 0. We're going to go through our 5 steps of graphing this, and then we'll take a look at the graph and see what that means about the answers. So step 1 is to decide whether it opens up or down, which in this case is up, since the number in front of x squared is positive. Step 2 would be to find the axis of symmetry, so x equals negative b over 2a. So the opposite of 4 is negative 4 divided by 2 times 1. So that would be negative 4 divided by 2, which is negative 2. So I'll go to my graph and put a dashed line along x equals negative 2. Next, I find the vertex. I know that the x value of the vertex is negative 2. So when I put negative 2 in for x, negative 2 squared is 4. 4 times negative 2 is negative 8. So 4 minus 8 is negative 4. Minus 5 is negative 9. So I'm going to go to my graph and put a dot right here. So there's my vertex. Step 4 is to find the y-intercept, which, as long as your equation's in the standard form, that's your c value. So my y-intercept is 0, negative 5. So I can go to the y-axis at negative 5, 1, 2, 3, 4, 5, and put a dot. And I know that due to symmetry, that if this is 2 units to the right of the axis of symmetry, then I'm going to have a point 2 units to the left. So I'm also going to put a dot right there. Step 5 is to do my xy chart. So remember, you stick your vertex in the middle and go 2 numbers above it and 2 numbers below it. We already know that at 0, we're at negative 5 from the y-intercept, so I know that's what goes right here, which would correspond to the negative 4, since it's also 2 units away from the vertex. So we got the negative 5 right there, which are these 2 points that I already graphed. So now all I got to do is put the negative 3 in or the negative 1 in, and whatever I get here is what I'll get here. To me, putting negative 1 in would be a lot easier than putting negative 3 in. So I'm actually going to use this one first. So negative 1 squared is 1. 4 times negative 1 is negative 4. So 1 minus 4 is negative 3. Minus 5 is negative 8. So it's negative 8 here, which means it's negative 8 here. So now all I got to do is graph these 2 points to get my parabola. So now that I've graphed all of my points, I'm going to take a nice smooth curve and connect all of my points for my parabola. Now back to the problem at hand. Remember, we were asked to solve this equation by graphing. So we graphed it, so now what does it mean to solve it? We started this problem by setting the equation equal to 0. So that would mean that y equals 0. And y equals 0 all along the x-axis. So therefore, I'm looking for the place where my graph hits the x-axis where y equals 0. So when we solve by graphing, we're really just looking for the x-intercepts. So once again, to solve by graphing, your answers are the x-intercepts, because that is where y equals 0. So for our graph, the parabola hits the x-axis at negative 5 and at positive 1. So my answers are negative 5 and positive 1. That is the solution to this quadratic equation. You can always check them by putting negative 5 in for x and 1 in for x and making sure that the left side really does equal 5. So once again, in order to solve by graphing, just graph your parabola like we have been doing with the 5 steps, and then your answers are the x-intercepts because that is where y equals 0. Let's look at one more example. So again, it says solve negative x squared minus 6x equals 9 by graphing. So our first step is to get our equation set equal to 0. So I would subtract 9 from both sides, so I'd have negative x squared minus 6x minus 9 equals 0. So now I'm going to graph this equation by doing my 5 steps. So since my a value is negative, I know my equation or my parabola is going to be upside down. My axis of symmetry is x equals negative b over 2a. The b value is negative 6, so it'd be positive 6 over 2 times negative 1, since again, your a value is negative 1. So 6 divided by negative 2 is negative 3. So I'm going to go to my graph and draw a dotted line along x equals negative 3. Step 3 is the vertex. Since we know the axis of symmetry is at x equals negative 3, my vertex has an x value of negative 3. So I'll take negative 3, plug it in for x into my equation and figure out what y is. So negative 3 squared is 9. So negative 9 minus 6 times negative 3. So that would be negative 9 plus 18 minus 9. So negative 9 and negative 9 is negative 18. So if I have negative 18 plus 18, that means my y value is 0. So I'm going to go to my graph and put a point at negative 3, 0. So there it is. Step 4 is to find the y-intercept, which as long as my equation's in standard form like we have it, your y-intercept is the c value. So our y-intercept would be 0, negative 9. So I'm going to go down on the y-axis and find negative 9 and put a dot. So since I know that parabolas are symmetrical, I can reflect this point over to the left-hand side. So it is 1, 2, 3 points to the right. So 1, 2, 3 points to the left. I know I'm going to have another order pair right there. Step 5 is my t-chart. So I start by putting my vertex in the middle, go 2 above and 2 below, knowing that these two are going to match up and these two are going to match up. So I'm going to take negative 1 and negative 2, put them in for x, and then reflect those points down here. After plugging those numbers in, I got negative 4 and negative 1, which means that at negative 5, it would also be negative 4. And at negative 4, it would also be negative 1. So now I'm going to take all these ordered pairs and graph the rest of my parabola. So then I will take a nice smooth curve and connect these points for my parabola. And remember, I'm now supposed to solve the equation by graphing, which means I'm looking for the x-intercepts. I could have stopped right here when I saw that my vertex was on the x-axis. In this case, unlike the last problem, I only have one point where the graph is hitting the x-axis. So I only have one answer, which means that this answer would be negative 3. So in some cases, your parabola will hit the x-axis in 2 spots, like in the last problem. In cases like this, you only have one answer because your vertex was on the x-axis, so you only have one answer for x. So back to the number of solutions. If your parabola hits the x-axis in 2 places, just like we did in example number 1, you're going to have 2 solutions. You will have one solution if your vertex of your parabola is on the x-axis because it's only hitting the x-axis in one spot. In certain cases, your parabola may lie all above or all below the x-axis, and in that case, you would have no x-intercepts, which means you have no real solutions, meaning you have no answers at all. So you could have 2 answers, 1 answer, or no answers at all. So here's a concept summary that relates the solutions of an equation, the x-intercepts of graphs, and the zeros of functions. If you are asked for the solutions of an equation, that means you set your equation equal to 0 and you solve for x. So in this case, you would have to factor, you get 2 and 6. If you were asked to solve it by graphing, you'd be looking for the x-intercepts of the graph. And again, you would still get 2 and 6 because that would be the place where it hits the x-axis. If you were asked for the zeros of the function, you would just put 0 in for f of x, which means just y. And once again, once you graph it or you factor it, depending on how you do it, it's still going to give you 2 and 6. So if you're asked for solutions to an equation, the x-intercepts of a graph, or the zeros of the function, you're really just finding the same answer in all three cases, just asked in a little bit different variety. That's it for this section. Make sure you jot down anything you didn't understand that we can cover in class before we move on, and we'll see you then.